Right. So if you are from Greece like me, you might know several commands to look around, uh, to move around in here. Um, I don't know if that makes any sense to you, but what we're doing is using I want to say help. Yeah, using commands. Okay, it's not help. But that brings it up anyway. Using commands like ping and then space dash something in order to get some sort of information out of the network, for example. You did not receive CyberVista login. Gemma, you might have to look into your MDC email for that. And I don't know when, but somewhere in week 2. Week 2 being somewhere around between 215 and 221, something from at CyberVista. It might be in your spam or junk folder. Yes. All right. So ping is basically what people use to attack your websites, send a bunch of pings, over burden your system in a way that it cannot keep up with all the requests. What is IP config used for?
Some like flooding, a bunch of
Right.
ping flooding.
Is an IP config used to like get the settings for your configuration?
For your network, right?
Yeah.
So in this case, it gives me a bunch of media disconnected, and I'll show you why. Because my computer has 1, 2, 3, 4, 5, 6 things. This here is connected to that. This is VirtualBox, Bluetooth, Wi-Fi 1, Ethernet, There's a lot of connections I don't really use. I use this one, and I use this one, and the rest I maybe should kill, but I have them there. So that's where the media disconnected come from. 1, 2, 3, 4, 5 disconnected, right? 1, 2, 3, 4, 5 disconnected. And then it shows, it's enabled, but it's not doing anything. Bluetooth, LAN 112. Yeah, it's not showing another one. Well, anyway, VirtualBox network uses this information for IPv6. This one here for IPv4, a subnet mask, which we'll figure out. And I did not put it so that it has access to the internet, so it doesn't have that. This Wi-Fi 2, which is called in my here, is how I'm connected to the internet. And that is giving me information about, my IP address in here, the gateway, and so forth. What can you tell me about my network from this information?
Class C.
Yes, you just read my mind. Class C. Why is it Class C?
It starts in 192, which is a beginning of Class C.
And if you didn't have this here, how would you know it's a Class C otherwise?
If I didn't have what? Sorry?
If you didn't have the highlighted part, my IP address.
Your
you can
subnet mask.
See, yeah, subnet mask.
And what is that giving you?
parts of the internet and the host.
Okay, so what is
255 is the internet, and then the 0 is the host.
It's a 24 mask dash 24.
right? So in
JavaScript.
CIDR notation, it would be what is it? 192.168.1.1/24, right? Because of the subnet mask. So the 255 meaning we're using all of the bits, the first 3 sections of the bits here to determine the network, and the 0 is the part that determines the host, right? Yeah. All right. There is another command with ipconfig that gives you a little bit more information. I mean, it gives you more or less, what would the physical address be, for example?
MAC address.
Yes, the MAC address. Let's go move on here. It tells you if the DHCP is enabled, auto configuration. It gives you more information, right? It tells you when the lease was obtained for the network connection.
The DNS server. Too.
That lease is an IP lease, or
I'm sorry?
the lease? It says lease obtained. What is the lease for?
Can anyone answer that?
From the
Yeah.
DHCP server, no?
That's the amount of time that that an IP address is assigned to a host, and that depends on the configuration on the DHCP server of the time that that host will have that IP address.
Correct. What if I have a static IP address with this appear here?
I'm guessing no.
No.
Let me see.
The default gateway is the router's IP. No, it's the router's network to go outside the internet.
Yes, but that's my internal, right? My local network address, because my actual IP it's different. This is my IP address. But yes, internally I have 192.168.1. Something that my router has set up. So I think currently I have like 30 something things connected on my network. So each one is assigned, of course, a different IP ending. And we'll talk about that in just a sec, right? All right, so that will be ipconfig. What is NSLOOKUP? There we go. Anyone? What am I finding or doing with that?
Any IP addresses?
For the servers?
The IP address of the network in google.com.
Yes. That's exactly it. Yeah, the book says it better than I would. You query the DNS database from any computer on the network and find the host name of a device by specifying its IP address or vice versa. So if I don't know, you typically go and say, okay, what's the IP address of this? Yeah. What else is going there? Dig I can't use because it won't work on my computer. It's
I want to ask you, Professor, I've been a little confused concerning the IPs. When the IP of the network goes, let's say it goes to Google, I'm basically touching the network, and then the network somehow gets another IP that actually goes to the exactly computer that it needs to go to after they're going to the network, after going to the router. So it goes to the router, which is an IP, is a specific IP address, and then it goes to the computer, which is another IP address that terminates communication with the specific computer in the local network. I don't know if that makes sense, but
I think I missed the question.
yeah. So when information is going to go to, for example, google.com, it goes to the network IP, and then the network IP has a different IP that goes to a specific computer inside the network to receive information and communicate. Is that what happens?
Let me find the picture. I don't remember, it's 3 or 4. Probably 3. Yeah, I think it's 3.
Also, it's probably the MAC address, right? The MAC address is the one who tells which computer to go to.
Professor, that was your computer that your internet is not working? Or-
This?
Yeah, I said somebody's computer was unstable. That was yours or mine? The internet.
I don't know. Mine didn't do anything, so maybe yours. I think it's this here. So all right, so whenever you, let's make this bigger.
Professor, where did you find that?
This is chapter 3.
Okay, yeah, but we just says it only has that read option. It doesn't have this, what is it called? Your slides, these slides.
Really?
I haven't seen that option. I was looking for that.
It's there. I found it before.
It is? Where'd you find it, may I ask? Can you show me, Professor? I'm sorry.
The lectures?
Huh? Why doesn't mine look different for some reason?
These are PDFs because I wanted them to be able to open here, so I put them as PDFs.
Mm-hmm.
And I'm opening the PowerPoint file.
Wait, I'm not sure.
But they're under lecture.
All right, thank you.
Okay. So the question is, how does a computer know where to go? Like, or data know where to go? Is that it?
Yes. After the network, yeah. After the router, sorry.
So I have a network with computers that go 192.168 something something, right? And it's a class C, meaning only the one at the end is the one that determines the host or the node. That goes out through a gateway. Actually, this is a better picture. That goes out through a gateway. And this address is transformed into something else. And each one of these, you see the, I can't highlight. 1 second. Each one of these here is translated into another one and goes out. So how do I put it? Each computer will be identifiable, like uniquely identifiable as it goes out through a gateway out to the network, the internet network or another network. This would be the IP outside, and these would be the IPs inside this private network, like your house or your office.
Oh, okay.
And then this here would be what we found when we went to what's my IP, right?
Mhm.
So what this device is gonna do is saying, okay, change this first one, right? The 120, the :80. Can anyone tell me that what that means?
Port 80.
Port 480.
HTTP.
Exactly. Yeah. So use port 80 to go out to. Yes, it's HTTP. Port 80 is used to communicate, right, with the internet. And transform this into this other 92, 52, 44, 1. You see, the same as here. But then you assign a different number all the way at the end.
Is this part of the transport layer? Switching the IP to the Mac? Isn't that part of the transport, or no? Am I wrong?
Let's go to. 1 second. Let me put the picture. So this part here, where we're making a connection, would be the transport layer. The network layer is where we're doing
Yeah, okay.
these things, right? This is just hardware, and this is where the where is it? Transport layer. Network layer. Data link is where you find the actual hardware connections and such. But I think you're supposed to go on layer 3 for this instead of layer 4. Layer 4 is what protocol we're going to use to connect, like TCP and such. Oh, speaking of this, okay, so this gets translated or transformed into something else, which then goes out to the internet. Everyone has a different IP on the internet, does its business, and then comes back. Let's say you're browsing, you're looking for a website. You go from your computer all the way from. Oh, no, not this. Where is that nice picture? Is it at the end?
Is it the DNS that makes the IP for the internet? The internet IP? Who creates that? Is it the DNS?
What are we talking about?
Okay, that when it leaves the gateway, there's an internet IP address that you were just showing. Who creates that internet IP address?
It's assigned to you by a server. So you see, here is where I'm looking at. The switch gives you 1 and 2, but you're really going through all of them. And when you leave your let's say private network, it uses the network layer with the router to determine where it's gonna go. So for transport is while on your computer still. Someone saying something? Okay, anywho. Let's move on to the next set. Can anyone tell me what netstat is for?
Well, that I know for sure is in the transport layer.
IPv6 IP of the server, Comcast or whichever.
So how do I find shit. I should have canceled some of this. These are all the connections I have. So if I do netstat dash n, it tells me what's connected doing to where, right? So it just gives me a list of connections on my local machines, including, as Ruben likes, the transport layer, which is usually TCP. Let me see if I can find others. Now, my computer brand is MSI, and you can figure out that there's a connection in here that's local because you see this number here, 127.0.0.1. Yeah, so basically what's the status, network status of your connections there? For tracer.
Tracer
Yep.
tells you how many hops it takes between your IP address and the location you're trying to get to.
That's what I was looking. What are hops?
The amount of the servers that it's passing through.
And what is what happened? What's the terminology for I want to limit those number of hops? I don't know if you can see that.
The TIL, TTL.
Yeah. And what does that stand for?
Oh, that's part of the one of the layers.
Hmm?
That's part of the layers.
Oh, well, yeah, but it's
Time to live.
to live. Yeah. So you can. So why are hops important for you whenever you set up a connection?
Measure your latency.
Okay. So what happens if I'm trying to find something and I just never get there?
Finds another way.
So it's important to have limits on your network connections so that you don't just wait forever, right? So the time to live will be a way to time out your network connection so that whenever it doesn't reach after a certain amount of hops, then it just stops the process and says there's time expired, basically. It's like saying, I'm gonna give you I don't know, 10 gallons of gas, but if you can't reach your destination by then we're gonna cancel. You know, we're gonna cancel the procedure. Let's see. What example? Sorry, someone's like drilling upstairs.
Excuse me, Professor. I have a. Do you take attendance? Because I was right here, but I had to go to real quick to the bathroom.
Yeah, I was looking at it. So let me see who's here before we move on. Wilfred, is Wilfred here? No. Jose. Yes. Ernesto. Fabian, no. Leandro is here? No. Jonas.
Yes, I'm here, Jonas. That's me.
Oh, you're up there. Okay.
Thanks. Thank you.
And Juan. No. Okay. Yeah. I got you.
I'm here. Did you get Christine?
I wanna say yes. What's your last name?
Mercedes.
Yes, I got you.
Thank you.
All right. So what can we do with this one? Let's see. Whoop. No, not this. What's it doing there?
Measuring the milliseconds it takes for each hop.
Mm-hmm. And then, because I didn't say after here how many, it defaults to 30 and it goes there. So it took how many hops to reach this?
14.
Yes, right? So it took 14 hops to reach from my computer to Google. Now let's go over and say,
So that means it went through 14 different servers to reach that.
right.
Got it.
Well, yeah. Where's the other one?
It has to be servers or switches.
It could devices. It doesn't have to be servers necessarily.
My bad. I'm sorry. Yeah,
Like
I used the
router.
word servers.
It should
Yeah,
be
like
router.
eventually we'll reach a router or a switcher thing that will get him to where it needs to go. But for ease of for for remembering, it goes through devices or pieces of hardware. Yeah, if you do, I don't know if you can see it. I'm sorry, I cannot make this a little bigger. Let's do 10. Actually, I should have this 14. 1 second. Well, whatever. So it's going through mine, right? The 192.168.1.1. This is mine. It happens to be called Ready Share. Then goes through this one, then through this one, then through this one. You'll see them all pop here. I guess it changed. Oh my gosh. Well, okay. Let me clear it out. All right, so there's that.
And Professor, the hops, the number of hops, I just got 11 hops. Does that mean that is for my internet connection server, like Comcast? Is that because the results that I'm getting, is it because of them, the internet company?
So imagine them as highways, right? And streets and intersections. So you're not flying a plane that you can go straight. And even if you were flying a plane, there's like highways in the sky, let's say, that you have to follow, like routes. So this here is, okay, from the origin to the end. You have to go through this street and turn here and follow that street and then this one and then that one and then this one, all the way until you reach your destination.
That's awesome. Thanks for explaining that.
Right. So
Thank you.
the hops is saying from this one here. So my computer doesn't count, but my router counts. That's one. And then the end, wherever their server is, whenever you go to google.com, this is where it gets to. But give me a second. Before it was giving me the names, I forgot what command I used. Might take a bit. If you do it quickly enough, these things don't change, and you'll see the same numbers popping there. But these might change because you get routed, right? Let's say there's a roadblock somewhere while you're driving, you might be rerouted. There's construction somewhere, right? You get rerouted, you go some other way. When you have a limit of number of hops, it means that you might not be able to reach your destination. When you don't have that limit, then it goes on and on and on and on. And this process can take forever until you just cancel it.
Professor, one question, please. Where was it? Okay, on that transfer commands, you have the -H. What's the 14 for? -H 14 google.com on the transfer.
The
command?
H, isn't it the number of hops?
Mm-hmm.
And then the 14 is how many hops?
Yeah.
Mm-hmm.
Okay,
Yep.
all right.
-H is the number of hops, and then 14 is the number you give it.
Oh, cool. Thanks.
And Professor, I apologize. I get little stars, and then it says request timed out. And then it continues 3, 4, 5, and then start again, and then request timed out, and then continues.
Yeah, it's giving you problem like -2.
Oh, okay. The highways are being used, I guess.
Well, this is a bad time to do anything, really, right? Not this, not this. Give me a second. Let's see if this works out. It was working. Of course, it works before when you're not around, but now it's not. Let's see. Because at some point it starts bringing Comcast IPs out for us so that you know it's a backbone, the internet. There you go. So if you don't put any dash anything and you just go tracer google.com, it starts telling you the names of these places where it goes and hops through. If you put -D and then google.com, you're saying, do not give me, the change from the IP addresses to the actual host name. You just give me the IP addresses like these. Right? This particular one, right? This here is called all this stuff. It's like mine is ReadyShare, but it really is 192.168.1.1, right? So it's resolving, it's giving you the options for this thing. It's just to see how it goes, where it goes to. It's tracking the progress of your data being sent through all the way from here to Google. I've been pinging Google all afternoon. Not that it does anything to them.
Why were you doing that?
Because why not?
They're
not gonna suffer at all from us doing this.
All day?
Well, not all day. For a couple hours,
Okay.
moving around things. Eventually, this ends once it reaches. It doesn't even have to be 11. It was 14, I think, to begin with. Then it came to 11. Now it's being kind of stuck on 10. But we are up to 30 hops, so I can have up to 30 of these lines giving me information. If you don't want, let's say you have you're trying to figure out how it's going from your network out, and you're in a subnet within a subnet, and you're trying to figure out how it goes, how your trace goes, you can say, okay, I want 5 hops only because I don't care about what happens outside my network. And it will tell you where it's connecting and where it's going as it goes through. What's the other one? Path ping. So what does path ping do?
Isn't it a combination of traceart and the ping command?
Yes. And it looks quite similar to this, right? Right, so path ping on tracer, they have the combination. You can play around with this. And TC dump, it's a packet sniffer. TCP dump, I'm sorry. But I don't have that. Have you guys heard of Wireshark?
Yeah, it was on one of the labs. We had to use it.
Right. So Wireshark allows you to see what's going on the network you're in and where everything is going, connecting from. So if you want to know what your kids are looking at without having to, suffer much through it, just connect that, put it on, and you'll see where everything on your network goes out. When Comcast comes around and says, oh, okay, you have problems with your internet, they'll run, utility with your network and figure out who's been going around on, the naughty sites and so forth. So everything is logged. You will find all this information there.
Even if I have a VPN?
No, it would show it's going to the VPN, but then, up an excuse or so. Yeah.
Is that the Wireshark? Is that what I just don't know, but would it be what the FBI and the CIA use to be tracking people's path, I guess, how they do, and like those people that do the porn sites and stuff? I don't know how they track all that. What do they, or what do they use for all that tracking stuff?
They could use this, or they could use their own. I mean, this is just where is it?
Mm-hmm.
Sorry, I have the controls. This is just the free. This comes with the version of Linux. I forgot. Oh my gosh. Oh my gosh, what's it called? Now it's gonna bug me. Kali. Oh my god, yes. Kali Linux. If you ever have had the disposition to try Linux and you want to mess with like pen testing and ethical hacking and all that stuff, you'll probably end up using this. It's an operating system. It's a Linux operating system that has all those fun things you can use, like Wireshark and so forth, to try out. This one's fun. To try out what different things on the network. So your FBI probably uses something similar to this, if not this already. So it's kind of cool.
Oh, thanks for showing me that.
Oh, yes, thank you.
So you could do this on like a little flash drive, install it on it, and just connect it to your Windows computer to test it out if that's what you want. And it takes a little bit of adjusting, like the command prompt versus the terminal is a little different, the commands, but it's a fun tool to use, even if it's just for the heck of it, not for work. You can try it out. All right, let's see. Now, let me turn around and let's talk about subnets before I forget. Chapter 8. Can anyone tell me what a subnet is?
Isn't it a tool that used to divide your network into sections?
Perfect. I'm glad to have people that are not shy about sharing. Thank you, Ike. Yes, so you basically have your pie, right? And you want to divide the pie in different slices. Each slice would be your subnet, right? Your pie is the whole network. You're saying, no, I'm going to separate it in two. You create two subnets out of that one, and thus you create two networks. So what's the purpose of us having a subnet? I mean, there could be many reasons, right? But give me some.
Security, organization of the network, and I think speed as well.
Yes, very good reasons why to have that. So let's talk about that. If you have your home network, for example, or a small office, right, where you have multiple devices connected together, where would security fit there and having a subnet then?
If one of your network is compromised, not the whole network, is only one section of it.
Oh my God. Yes. That's so you might have different rights for different networks, different subnets. So the one that you use might be super, hard to get to. It might have a password that's as long as the whole ABCs and 1, 2, 3s together. And you may also have a guest network for whenever you have people coming at home, that you don't necessarily want to give access to all your stuff, but they want to browse the internet and so forth. This is something that your router may already be doing. So you might have, like my router has the 2.4 gigahertz band, then it has a 5, and then another 5, and then it also has guest networks for each one of them if I want them to, right? So I could separate them without having to worry about the whole what's going on in the background, because I don't know anything about networking. So the router itself is giving you the option of doing that, but you could do that with anyone. It doesn't have to be the device that does it for you. So speed, you said speed. How does that come into play? It doesn't have to be Ike. It could be anyone.
I don't think it does. Subnets, I don't think it has to do anything with speed. I'm not
You
sure.
could configure one particular subnet to be prioritized over others in terms of access to resources.
Well, some subnets can improve the performance of the network. If you assign a subnet, let's say like for a different department on a company, like accounting is on a subnet or a VLAN, and human resources is in another VLAN, that would improve the performance of the network of that company.
For that branch.
Exactly, yeah.
Right. So if everyone's fighting for the same to walk through the same corridor versus each one of you has their own, it would simplify things, right? So there will be times where the network will be congested normally, that's normal. But yes, separating them will allow you to create this to take away this bottleneck that would otherwise come around from having it all together. Also, it's easier to figure out problems when you have subnets than when you don't, especially if you have a lot of devices connected together. So why are some things working and some others not? A good idea would be to check the hardware on the subnet where things are not working. maybe, things of that sort. So dividing is not a bad thing. Obviously, if you have 5 things, you do not want to create one per. It kind of makes managing a little harder on your end. But if you have 300 of them, maybe like, I don't know who talked. I'm sorry, I don't know your voices yet. But separating them into like accounting, HR, and so forth, that would make sense for your company, right? Because it's, I don't know, maybe you have 10 people in HR and you have 20 people in accounting, and you assign them their own so that they don't have to be fighting for resources all the time. All right. Let me see if I'm missing something. All of that is in there on the slides for you to see. Now, IPv4, which is where we're going to do the bulk of the subnetting part. Talking about, has something called class, addresses. So can anyone tell me what, we talked about class C, right? But what are these classes? What are we referring to?
Is to know what is the appropriate IP location. There's some IPs that are for the government, for some of them are private, some of them are public. So just to differentiate between the different IPs.
Right. So what's the most commonly used for, like, let's say you and me? What class of IP would we be using?
Class
C.
C.
Someone else said something? Yeah, class C would be what you would be using, let's say at your home network, for example. And when does class C start? Let me see if it's here. There you go. No, it's not this one.
192.
Yes, it's 192.
For class.
So let me.
That stuff, all the bits. Is that really necessary? And in the future,
Oh my God, you're gonna.
all that counting bit stuff. I understand dealing with the IP addressing, and the subnets, but then counting all those pins. So yes or no?
So
is that yes, Professor? Or this is
you're gonna need to count the dots and stuff.
Okay, my friend. That's what I want.
So let's start from the beginning.
All right.
What does the computer know how to read or decipher? What language does the computer?
Binary code.
Right.
Binary.
What's binary?
Zeros and ones.
Zeros and ones. Can you see my screen?
Yeah.
Right. So off or on, right? Or true or false, or some sort of binary, do two-way depiction of the truth. So your IPs come in groups of how many of these zeros and ones?
3. No. I'm sorry. 8.
8 for 8. Octet.
Yeah.
Right. Each one of these numbers, like the 192, and then you have a dot, is separated, and this is 8. What are these in computer language?
Octets.
Bits.
Which, yeah, it's an octet. Yeah. Sorry for the bad handwriting. It's hard on the mouse. So you have 4 of these here. And we said we use class C. Class C has a subnet of 255, 255, 255, and then 0. What does that mean? The first 3 octets, right, are being used for the network. And then the last octet, the one that has this 0 here, is for the hosts. Easy enough because we know, let me use a texting. So we know if we have 192.168.1.1, my network can take up to 192.168.1 dot, anyone?
255.
255. So my network starts here and my network ends here. And anything in between, anything here will start 192.168.1 and be assigned a number, be it 2, 3, 5, 25, 150, 215, whatever it is. But the only thing that changes is this last number. That's why, because we decided that we're going to call this our network, and this is the number of hosts. All right, what is this in your network? What is this first numbers supposed to be?
Your gateway.
Give me another name. Less IT-ish.
A router?
Okay, that works. And what's this other one then? Actually, I'm sorry, it's like that. Here I'm messing around with you. This will be the broadcast. It's important for you to remember the broadcast is just used to communicate with the rest of the network. We don't necessarily care about it right now. Here, anything in between will be used as hosts address. How many hosts can we have in a network like this?
254.
254.
Is that right?
You tell me. I'm just typing what
Yeah, 254.
I'm guessing.
you.
I'm guessing 254 because we can't use 255 and we can't use 0.
Yes. All right. So the question would be, how many addresses in total do we have?
Yeah, 254.
But in total.
Oh,
Total,
256.
256. If we
56,
take away
because
2, right, the gateway or the broadcast, you reach the 254.
Mhm.
This is important for you to remember because for every subnet that you create, you're going to take 2 out of whatever is in there, right? But initially, you have 256 addresses that you play with. That you take 2 because of reasons, then that's another story. Where does this 256 come from? I hate that it picked that color.
The number of binary bits.
And what is that?
All 8 ones equal 256.
So 1, 2, 3, 4, 5, 6, 7, 8 in binary is the same as 256 in decimal. All right. Can someone explain to me how we got all those 8 ones and transform them to our decimal? Okay, let's make sure the decimal system is what we know. So decimal system means there's 10 numbers. 0, computers always start at 0. 0, 1, 2, 3, start counting with your fingers. When you reach 9, you got 10 numbers. The moment you go to 10, you increased from only 1 digit to 2, but you're still using 1 and 0, which is part of that group. If it was binary, which is base 2, there's only 0 and 1, right? And then there's no more. There's no 2 or 3. So how do we know that this number is really 256? How do we transform this 11111 times into decimal?
You make a table of the multiplication of 2, and then you count each one to get you to 256.
Okay, so let's make a table. Let's use Excel. So I'm gonna do this. 1, 1, 1, 3, 4, 5, 6, 7, 8. You can see these nice numbers here. I'm gonna center them. I'm gonna make this actually smaller. All right.
What
Can
are
you
you
all see
showing
that?
us? No. What are you showing us?
Oh,
Yeah,
sorry.
nothing.
Screen 2. There we go. You see the Excel?
Yes.
Yeah, we
Okay.
see it.
So this is binary. And in decimal, we said this was 256. All these, to transform them into decimal, you have to go 2. Why is 2 such a big deal in computers? 2 to the power of, what's here?
1.
2 to the power of 1?
There's a 0.
2 to the power of 2? Is that it?
Mm-hmm.
2, 3, 4, 5, 6, 7, 8. Oop, I added one more. That's why my math wasn't adding. This is really like this. Well, it's 2 to the power of 0 always starts on 0 on the right side, and you start adding it until it's 2 to the power of all the way 7. Oh. 2 to the power of 6, 2 to the power of 5, 2 to the power of 4. I mean, that little like V, inverted V, that's a power, right? Sign. So I'm saying, okay, let's start with the easy one. 2 to the power of 7 is the same as saying 2 times 2 times 2 times 2 times 2 times 2 times 2, right? 1, 2, 3, 4, 5, 6, 7. 7 times. How much is that?
128.
128. 2 to the power of 6 is the same as saying 2 times 2, 6 times. How much is that?
64.
To the 5?
32. 16. 8. 4. And then 2.
And then
0.
1.
1, my bad.
yeah, 0 confuses us for whatever reason, still in our, in our adulthood. But yes, it's 1. Anything to the power of 0 is 1. So these numbers are going to be important for you to change this into this. So assume that if a number is a 1, it's on, and if it's a 0, it's off. So we knew that all those ones together are 256. So 256 is the highest number we can get from an octet in binary.
It's actually 255 if you add it up.
Yeah, I was about to say the video that I've seen was 255, wasn't 256.
250. Well, thing is, what's this then? Oh, it's 255. You're right. This is 0. The thing is, it goes from 0 to 255. That makes 256 numbers. That's why it's always messing with my head. But yes, you're right. Because the subnet mask of This is 255, 255, 255, 0. You're correct. But know that there's 256 numbers in there because 0, we start counting at 1, 2, 3, you know? So if you start counting at 0, 1 becomes the second number. You're correct. All right, so all these zeros mean nothing is on. So when you convert into decimal, you're doing 0 times 128, 0. 0 times 64, 0. 0 times 32, 0, and so forth. When you add these things together, they give you the number in decimal. So let's, does this make sense? It's kind of hard to do this on the computer. What happens if I give you this number?
Then you have to add 32 plus
42.
8 plus 2.
And how much is that?
42.
42.
Right? Is this making sense for all of you, or is someone not? That's fine either way.
I
got it.
finally understand.
Yeah.
I think it's like the third class I've taken that has shown me this, and I finally understand it.
I agree. I agree. I've seen so many YouTubes and it just wasn't like, no way, this was good. Well, a lot of those YouTubes are like in Indian language, so it's kind of hard.
Yeah.
Well, if you do not know Hindi, that's the
Hindi.
first problem.
Yeah. So,
But
but
yeah,
you did great.
You
Mhm.
start from right to left, as if you were reading Japanese, right? And you start giving 2 to the power of something all the way to 7, which is 128. When you add all of these together, like we said before, right? It will mean 1, 4, 16. I'm using Excel and I'm really not using Excel. Why do the math if it's gonna do it for you? So if I change this and I say it's off and then this is off, it's really 253, right? If I say 0, 0, 0, 0, 0, that means that this is, well, actually, yeah. Why don't we use Excel?
That was pretty cool. That's an Excel program you said you're using?
This is just Excel, yeah. So now I'm putting
Wow, it's pretty cool.
1, 1, and it's gonna give me what the decimal number is just by using Excel.
How did you start that that feature that you're using, the adding up like that? How'd you start it
This
out?
is just multiplying that 1 times the 128.
That's what
A1 times
And then
A4.
this is just adding all those bottom numbers. This is very simple to use. I mean, you don't have to do that. And there's calculators on the internet anyway. But you need to be able to say, okay, this is the binary number I have, and I have to transform it into decimal by using these numbers. And it's like punching a hole on a little card saying, I have this one, I have this one, I have this one, and all the other ones are zeros, like here. So I have this one here, I have this one, I have these others, and those add to these numbers, which later are put together. You know, you add them, and it gives you the number in decimal. So 10010011 binary is the same as 147 in decimal. And you can create these. And if this were other times, I would slap a a subnetting test on you with base 7, base 8, hexadecimal, binary, and decimal all together, because it's super fun. Probably not so much for you, but it's fun to change from one base to the other. And generally, it's a 2-step process, right? But I'll show you. I don't know if I have it here. I'll show you what kind of exam I had. Resources. No.
Professor, is it okay to start from 0, 1, 2, 3? No, from 0, 1, then 4, no, 1, 2, 4. Start with a 0. Is that okay to start with a 0?
Where?
See where it says 1 and then 2, 4, 8, 16, 32, 64. Is it okay
Yes.
to put a 0 before the 1? Like, make another, or you can't make another section, right? Because the 0 needs to be there, right? It's part of the binary, no?
I'm not sure I'm catching on to what you're saying.
Well, the binary is composed of zeros and ones, and I wonder why the 0 is not mentioned in the. So you gotta start with 2 times 0, or 2 to the power of 0. That's
Okay,
the
okay.
answer.
So binary is another way of saying base 2. So that's where this 2 to the power of something comes from.
Oh, got it. Okay.
So 2 to the power of 0 is because there's 2 numbers only, right? And you're saying, well, this bit is 0, this bit is 1, this bit is 2 to the power of 2, 3, 4, whatever. So but everything in computers, because it's in binary or in base 2, is related to this. I don't know if you remember, I don't know how many of you are a little older like me, maybe not like me, but the evolution of RAM, you started getting I don't know how far back, but let's say 256 RAM,
Yeah.
512 RAM, and before this was 128 whatever RAM, and now we got to the 1 gig 1 meg of and so forth. This really is double this, but we just say 1 megabyte because it's easier to remember, because we're all dummies for remembering things. We're not computers. So 1024 is 1 megabyte, but 1024 bytes, right, of stuff. All these numbers come from your base 2. So when you're saying you have 4 gigs of RAM, you really don't have exactly 4 gigs of RAM, right? I think it's like 4096 or something like that.
Yeah.
But I'm sorry?
I was just agreeing.
Okay. So all of it, everything the computer has and does has to do with this 2. So the 2 is like the
leader.
This magic number that makes everything fall in place. And another thing you have to remember is you start counting at 0, which is something we do not do as people, because we don't have 0 things. We just have 1, 2, 3, etc. You don't have negative things, right? Unless we're talking money, where you can go in the negative. But either you have them or you don't have them. Let's say I have 1 phone, or I don't have a phone. That's 0 phones. But we don't count 0 phones, 1 phone, 2 phones. But the computer does that. So it's kind of confusing to get it at first. But anyway, yeah, everything goes with these numbers. So you don't have to remember these, but you have to remember where they come from. That way you will never forget. I don't know if that makes sense. This is not what I wanted to do. Yeah, I had a book chapter where I would show you how to transform from binary to decimal and hexadecimal. And I would take an exam of this, and it was a fun class to teach because numbers are great. But they give you all these things in order. I can put them if you want them, but hexadecimal, for example, has 16 values, right? That's where the hexa part is. But we only have 10 numbers. So then we start getting A's and B's, C, D, E, F. 1, 2, 3, 4, 5, 6 beyond the 10.
And that's what MAC addresses use, correct?
Well, yeah, because the combinations, it's like getting the lotto, winning the lotto. The combinations are so vast that it's hard to run out of numbers. Yeah. Also, IPv6 uses this and also other, other ways. And so it's basically impossible at this point to run out of IPv6, but we've been running out of IPv4 addresses. That's why we use that conversion from your local to the outside and so forth. I do not know where it is. This is really annoying me because I had a really cool exam and I wanted to show you, but maybe another time. Network troubleshooting. Oh, I'll give you this one. I forgot I had this. So I explain all of these things so you can have, and the sources here anyway, so you can see what I put there. I hope it still works. It's been a bit since I used that site. Yes. So go onto that site and start looking into what all these things do, and then this, it explains all this stuff. SolarWinds, why is SolarWinds coming up so much? Anyway, what I did with this is just synthesize all the information. Anyway, yeah, I'll remember to put that there. All right, so if I tell you, all right, I'm gonna get out of this and I'm gonna clear all of this, and I say change this and put it into binary, what would you do?
You're gonna start with the left. You have 128, and then
64.
32. 64 is out. 32.
Yeah.
16. 8.
Then we're
And
just gonna write
then
them all under it.
2 and 1.
2 and 1.
This times 1, it means that it's just on. Okay, I just started and then went on with it. So the zeros, this 0 would be the 64. This 0 would be
8.
Yeah,
and 4.
I'm reaching the limit, so it doesn't let me type all the way up here. It's the bar. So the 64 is out, the 8 is out, the 4 is out, but the rest is there. And then you just have to use high-level math and add, 128 plus 32 plus 16 plus 2 plus 1. And what number is that? That's 10, 8, 9. That's 19. I think it's this. I'm on the spot. So that's your decimal equivalent for this number. So why is this all important? Because I feel like I've taken a turn because I like this. You will get questions where you will be told the subnet mask for this network is such and such and such. It's 255.255. Let me find something nice. That way I don't have to make it up. 240 and then 0. What can you tell me about this? If I only give you the subnet here.
It's a class B.
No, we're talking class C. It's a class C, and we're talking subnets. I'm sorry, I should have maybe started with that. To understand this, I will tell you to go, oh my gosh. Where is my chat? You can go to this Wikipedia and go here, where it talks about CIDR. The one I put in there had a mask of 240. Oops, too much. 240 and then 0. Meaning what? That you have network piece, ABC, right? This is a class C host part, but we are taking from the network part 4 bits. We're borrowing 4 bits in order to create a different kind of modality, a different kind of version of our network. For
Was
what?
it slash 28?
Well, no. Now you're making me. No, it's 4 less. Yes. So it's slash 20. Our regular IP addresses are this. You have ABC, right? 255, 255, 255, and then .0, meaning you're using out of your. Wait, am I sharing my?
Yeah, I can't see anything you're doing.
This is so annoying. Can you see this?
Yes.
All right, that website I put in there, any regular class C IPv4 address looks like this. It has 3 network components, ABC, which count as the, those 8 bits, 8 bits, 8 bits, and then 8 bits. So this is the network, and this here is the hosts. That's a regular class C address, where this could be 192.168.1.0. This is your gateway, and it goes all the way down to 192.168.1 to 255, which this one you don't use for hosts, and this one you don't use for hosts, but everything in between 1, 2, 3, 4, all the way to 254 you can use for hosts. This is your typical here. You can make a different network to create subnets in order to have more or less hosts in your subnets. You only have 32 of these, right? 8 times 4 is 32. Meaning if you took an address like this, it would mean that the network address is all of it, meaning there's only one network there, which happens to be the host route, and that's it, nothing else. So we kind of go in this realm. I would say somewhere around here-ish. Yeah, you can have 4, but what's the point, in having only 4? The number here in this box, is telling you how many addresses or hosts your network will have, right? Is this making any sense?
Like, you mean if the company has 50 computers, it will be reflected in the type of mask, right?
If you use the regular, this one, right? This one here, this regular one, you have 255 slots to assign computers to. So you don't necessarily have to have them all used, or right? So if you don't do anything on your network, you just plug in your router at home, and it assigns you on, you know, Wi-Fi and all that stuff. You create all that. The moment you start adding things to your local network, your computer is automatically going to give it one of these numbers: 192.168.1.1.1.2.1.3, all the way until you reach 254. Up to there, it will be like, okay, I don't have any more slots to give. You've grown too big. So the idea here now for subnet, and I'm going, I think I went too far in my explanation, is that you want to create the subdivisions from your network for a particular purpose. You name it: security, efficiency, speed, troubleshooting. You want to test something on the network and you don't want to mess with everyone else, for example. So this here is important for you to look into: CIDR notation, which says this is your IP address, and the slash, / and the number here is saying how many out of these bits. Remember these 8 bits, 8 bits, 8 bits, 8 bits. That makes 32. So 8, 16, 24 bits. 24 bits here make the network, well, it's saying it down there, make the network ID, and the rest make the host. So this way it's telling you, look at this, we might have a change. So if this was, instead of a 24, it was a 25, then 25 bits, meaning, where is that chart? Meaning, oof, this is so small. One of the bits from here, from this last octet, right? 192, 168, whatever, has been borrowed to give it to the network section. If it was 192, 168, 89.0/23, then the host part will be borrowing one of these bits from here to create a different kind of subnet. I added this part. I'm gonna post it differently because we need to understand what we're doing. Let me see, where is this? So let's say I'm telling you I want you to create 6 different networks within this one network, right? So I want you to do 6 subnets from this one network that we have, this one big network. What do you think you would do? You would have to divide the 200 and, let's say technically 256 addresses into 6 parts. You're all here with me?
Yes, yeah, but I don't understand why 6 parts.
Because I asked you, because one is going to accounting, another one is
Okay,
going
yeah.
to HR, another one is going to, I don't know, you name it, you know, finance, some other. We can start small. So if we have one network, how many total IP addresses do we have?
255.
256.
256, sorry.
You count from 0. Yes. If I tell you split that into 2 subnetworks, right? Into two subnets.
Hmm.
You would do it equally. Let's start by doing that. Well, you would do it equally. How many IP addresses would then be per subnet?
128.
128.
Which is a /25.
Yes. And if I tell you I don't want 2, I want 3, what would you do?
/26, 64.
All right, so can you see the Excel thing again?
Mm-hmm.
All right. So one network is 256 IPs. 2 networks is 128.
I mean, 2 subnets.
Okay, sure. 128 each, right?
Yeah. Yeah.
Meaning we have 128 times 2, which is the same as saying 256, right?
Mhm.
So if I want 3, then comes the problem of 3. Remember that the computer only understands base 2. 3 doesn't appear anywhere here. If you're using, if I tell you create 3 sub networks, you have to basically create 4, because as I'm sorry, I don't know who said each one will have 64. Because if you add 64, 64, 64, 64 together, you get 256, right? The total amount. Why 4? Because it has to be a number that qualifies with this. You need this many number of subnets, then you have to do 2 to the number of however many bits you need to borrow to be able to create the subnets. And 2 to the power of 1 is 2. 2 to the power of 2 is 4. But if y is 3, I will never land on 3. You need at least a number that either is the same or more. If my y is 3, well, let me put annotate. So I say y equals 3. I want 3 subnets. 2 to the power of what gives me 3 or more. You go 2 to the second power, which is 4. Is 4 more than 3? Yes. 2 to the power of 1 gives me 2. Is 2 more than 3? No. So I have to stick with this one. And you can leave one network unused. You don't have to use them all. You can just leave it there, waiting for, gathering dust, as you would say.
Professor, I want to ask you something that I was thinking right now. Since we cannot use the 0 and 255, we can use those 2. Why would you divide to 64 if one of the 2 of them, there's 2 of them that you cannot use, so you're really not being fair in divided by 4. It should be 63. 63 times 4 is 154. It is 254.
That is a good observation. But every time you create a subnet, you're basically going to take away, and that's on this here. You're basically going to take 2 away. One will be, anyone? The gateway or the router, right? The address for the router. And the other one will be the broadcast. So while you have 64 different ones, let's start with 1. You have 256, but you really can use 254, ranging from 1 to 254, right?
Mm-hmm.
Yes.
Because you cannot use a 0 and you cannot use a 255. Now, if you subdivide it into 2, I'm sorry, I'm running over, I think. If you subdivide it into 2, you will have 128 But out of those 128, the first one you cannot use, and the second one, and the last one you cannot use per subnet. So you will essentially be losing 4, 2 in the first one, and 2 in the next one. So the number is reduced from 254 to what's half of 254? 127, 126, 126.
Oh, I see.
So these are the usable for hosts, right? All this stuff. You will always take away the drawback of using subnets is that you have to lose one for the network itself, the little subnet that you created, and another one for broadcast, and everything in between becomes a host. So initially you can only use 254 out of the total of 256. When you subdivide it into 2, you cannot use the first one, which will be, let's say, this one, and you can also not use this one, which is, these are the first
Oh,
IP per subnet, and the last IP per subnet would be what?
Wouldn't the first for the other one? Oh, never mind.
So if we divide it into two subnets, I'll make a video of this to make it better. I think this does deserve a video. You always start with 0. See here? The next subnet, you're gonna add one, whatever number it is that you have per, and then the last one for the first one is 1 less than this. That's why I knew immediately it was 127. Let's go to the next. Let's say I'm dividing, forget 3, I'm dividing it into 4. Each one of these will have 64 IP addresses. Which one is the first subnet gateway address? The very first one as normal, right? Which one would be the next subnet?
63. Oh, I'm sorry, 64.
Yes. Whoop. Why is it 64?
Because the 256 is divided into 4.
you're
Yes.
making 4 subnets.
So what is the third one?
128.
And the fourth one? Am I right? Is it 192?
Yeah.
All right. The first thing you're gonna construct when going through to get a, if I tell you, given this IP address or given this subnet mask, whichever way, we'll practice next week. Given this subnet mask, give me the first usable as a host IP address of the third subnet. Which will be the first usable IP address of the third subnet?
129.
129.
Yeah. Whatever. 129. Is everyone getting why? Is Ruben still here? Okay.
Now, this only happens because we're making 4 subnets, right? If we make 2, that's, everything changes.
If we make 2, this goes away, this goes away. And
Okay.
this is the first one, and this is the second.
Professor, yes, I am here. I couldn't unmute myself.
That's okay.
Yeah.
Now, let me give you a problem. I want you to give me what am I doing here? The 192. The 168. Okay, what's 192? I don't remember. 192 is no 1. To this 168 is what? I think it's 10101. I'm transforming this number into binary. Are you following me?
Yep. Yes.
Right? I mean, one is just,
All zeros except for the last one, which is a 1.
right? Oh my God. I should made it text. Text. Okay. And then the 0 is just one bunch of zeros. Who cares? This part, bunch of zeros. So 192, 168, 1 and 0. This is my IP address. What is happening here? This is the network portion of my class C IPv4 address. But what does it /28 say? There's 8 bits here, 8 bits here, 8 bits here, 8 bits here. If we add these together, give me 24 and 8. 24 bits make up the network section and 8 make up the host section. The /28 is telling me that I am borrowing
2 bits.
these 2 bits to create subnets within my network, right?
First, I didn't get about the 24. What happened?
I'm sorry?
Yeah, can you explain again the how you got the 24?
Yes. So every single number before the period here, right? That separates your IP address consists of a series of zeros and ones in groups of 8, or called octets. This 192 is the same as saying 110000, right? 192 in decimal is this in binary. That's how I got this one. And the 168 similarly, and the 1 similarly, and the 0 is just a bunch of zeros. In a class C IP address, the first 3 octets, meaning this is 1 octet, another octet, another octet. So the first 3 octets, that's where the 24 comes from. The first 24 numbers, 0 or 1, are what the network is. So it's like saying you live in an apartment building. The apartment building is 12345 Southwest 88th Street, but my apartment is 201. So 12345 would be this part, and apartment 201 would be this part. Right? This is the address that will lead you to my complex, to my apartment complex, and this is where it will actually lead you to my door. This is telling you what device within that one network is connected through in this IP. Clear there?
Yes, thank you.
All right, so we're borrowing 2. Why? Because of this. This /26 is very telling. This is called CIDR notation. It's telling you, no, this is not a normal network. This is really something else. It's a subnet. You're talking about subnets here. So, all right.
Hey, Professor, one question. You know how you're changing there the ones and the zero on the top, and it starts adding and subtracting the decimals. Is there another way to do that? Because I see how you change them, and I mean, if I don't have that the program that you're using, the Excel, how would you do it? The adding and subtracting to find the right decimal.
Pen and paper.
128 plus 64 plus 32 plus 16 plus 8 get calculated. That's the one way.
Oh, right.
Yeah, this is the number. Actually, the number that you're going to be given, it looks like this. And you have to figure out how to turn each of these numbers in, before the periods. How do they match up in binary? This is one of the first things you have to do. So then you say, okay, this is my binary 192, 168, 10. And I highlighted or turned red the ones that are the network portion of my IP. So what am I doing here? If I took two bits, how many subnets can I get out of this?
6.
Why 6? Remember, 6 is not 2 to the power of anything.
Oh, 2 to the power 6.
What does 8 minus, well, 8 minus 2 does give you 6. But you cannot get 6 subnets. You might use 6 subnets, but you don't necessarily get 6. What I mean is, I either have one network, 2 subnets, 4 subnets, 8 subnets, 16, 32, 64, or 128 subnets. Actually, this is really unfeasible, but you have these. It cannot be any number different than that. Will you use 8? No, I could use 6, I could use 5, but they have to be separated. Let me see if I can. I think I'm making it worse for you. Okay. Look at this chart on slide 15, I think, on yours. Your regular subnet mask. Your regular IP address is /24. The subnet mask will be 255.255.255.0. You will be able to have 256 subnets. Yes, you will be able to have 256 hosts, let's say, IP addresses, but you will only be able to use 254. Because the first and the last one you don't use. If I borrow 2 bits, the notation will be this, /26, the 192, 1 whatever. My subnet mask changes into this. Why? Because if I borrow the first 2, it's the same as saying, you always borrow from left to right. This is another problem. The first one is worth 128 as given by this. The second one is worth 64. The third one is worth 32. Your subnet mask for this particular network would be 255, 255, 255, and then what? Yes. I mean, it's given here. But yes, 192. Why? Because we took the bit that corresponds to the 128, and we also took the bit that corresponds to 64. And when you add these together, it gives you that. A subnet mask, remember, it's on a regular 24 is that full numbers, full ones on each one of the octets. So if you have
So
one,
essentially on the test, the bits that you're taking away are the most important. That's the one that pretty much give you the answer, right?
yes.
Okay.
So when you're going on this exam, I'll prepare something for you to practice. You'll have to look at this. You have to transform that into this notation, right? The CIDR, you transform it here. You'll figure out, or maybe they'll give you this here and say, what's the CIDR notation if I give you the subnet mask? How many subnets can I do out of this? Well, 2 to the power of 2. Why? Why 2 to the power of 2? I made it all big and I don't know where it is. This. Whenever you're trying to figure out how many bits to borrow to create a certain number of subnets, you use this little equation here, where n is the number of bits that you need to borrow, and y is the number of subnets. So if we borrow 2 bits, we already got n. So 2 to the power of 2 is
4.
4. So we could do 4 subnets with those 2 bits that we borrowed. You could say, the question could be like, how do I create 3 subnets? How many bits do I need to borrow? If I only borrow 1, and I put, instead of n, I put 1, 2 to the power of 1 is 2, and I need 3, 1 bit is not enough. I need another bit. Let's move on to the next. So if I want to do 17 subnets, for whatever reason, how many bits do you think we need to borrow from the host section to give to the network section of your
32.
IP? You start saying, okay, 2 to the power of 1, 2 to the power of 2.
32, right?
I'm sorry?
32, because 16 is below 17.
Right, so how many bits do you borrow?
32.
Not 32. You only have 8, remember? Look at this. You can only
24?
borrow
24?
32 is the right answer in terms of 2 to the power of something, right? So if you see here, you were right. If 16 is not enough, the next highest number, the next number on the base 2 would be 32. So you need to borrow 5 bits. So this would become, all the red would be network section and the black would be the host. Now, I won't be using 15 of those, but I would have to create them nonetheless. So if I say, okay, we're gonna do 32 subnets, which one's the very first IP? It's the same for every single one. I mean, they will give you the IP. So the ending of it will be the same for all of them. So this is subnet 1, subnet 2. How do I know how subnet 2 ends?
248.
248.
Wouldn't it be 32?
Because you
Why would you say 248?
count all the zeros in red. and you add them up?
No. All right, it's 32. Why? Because you have divide. Okay, what's ah. What am I doing? 16. 256. Actually, it's 8. 8, 8, 8, 8, 8. You have to divide the total number of hosts or IPs that you have by the number of subnets that you have. So this would be 8. The third one would be the fourth one. Remember, there's 32 of these. Okay, so forget 5 is too much. Let's go to 3. I don't want to keep it too long. What do you know about this? Let's start from there.
Class C.
Gonna borrow 2 digits.
Yeah, this is a class C. And because it's not /24, you have borrowed two bits. What is the subnet mask for a regular class C?
255.255.2550.
Yes. What would be the subnet mask for this one here /26?
255.255.255.192.
And how did you get there?
By adding the total of the first 2 bits, 128 plus 64.
Yes.
Because those are the 2 bits you're borrowing.
Right. So this is the end, right? 5, 6, 7, 8. This is the last octet, the one that refers to this here. And we're borrowing these 2. And these are in a predetermined order. The first one is 128. The next one is 64. And if we borrow these, we have to add them together to reach this number here. Is it?
Excuse me, Professor. I'm sorry, but sorry to interrupt, but I have to. I have a errand to run right now.
No worries, no worries. I know I'm taking away from everyone's time.
Thank you.
I'll try to explain this better next class, I think. I'll think about another way. How about this? Let's stop here. Read on subnet. Look into CIDR notation, and then we'll pick it up next class from the start. That way we make sure everyone knows, because it's important for you to understand what's going on this. And I hate that this class is always running around. It's always not you guys. This course in particular, there's never enough time to talk about things.
Professor.
Yes.
By this week, we were supposed to already read chapter 8, or chapter 8 is due for the next week?
What you said last.
Okay, so
it's for next week, not for.
So this week we're supposed to read chapter 8 and do the questions and everything.
Yes. So if you read chapter 8, yes, William, that's correct. If you read chapter 8, it's all about subnets.
Okay.
So read it, and I'll just ask a question, and at the beginning of next class, and be like, If you can solve this, then you're good to go. But if you can't, then we'll explain what happened.
Okay.
We'll do that. Yeah. Yeah. So every time you take a quiz, if you want to be given credit for it, you just upload the screenshot of the quiz onto Blackboard on the respective area, and you'll get there. For now, try taking, quiz 1, 2, or 3, or all of them if you haven't done them already after reading chapter 8, and you should be ready. You should read 1, 3, 4, and 8, and that basically covers the first 2 quizzes and maybe part of the third. Yeah. It doesn't matter when you do it, as long as you do it by the end of the semester. It doesn't matter to me.
And you'll be uploading the video for chapters 3 and 4 tomorrow, correct?
Yes.
So 2 is not part of that, right?